Okay, for example 6, that it asks us to factor, and we have an x to the fourth and an x squared. So this means I'm going to factor with x squared and x squared, and then to multiply to make negative 20, add to make negative 1, I would choose negative 5 and positive 4. Now in the past, we'd be completely done factoring because x squared minus 5 doesn't factor because 5 is not a perfect square. X squared plus 4 would not factor because it's a positive. So this has a name, and this is called irreducible, which means it doesn't factor, over the rationals, which means it doesn't factor anymore with rational numbers. Okay? Well, now we can do something with this. If we want to say that since 5 is not a perfect square, I can call this x plus the square root of 5 times x minus the square root of 5. That'll leave me with x squared plus 4. And this is known as irreducible, which means over the reals. Okay, that's what that means. Irreducible over the rationals meant no square roots, no i's. Irreducible over the reals means there are square roots, but no i's there, meaning no imaginary units. Well, now I can try to factor this x squared plus 4. And how would I factor x squared plus 4? Well, I'm going to recopy the x minus plus square root of 5x minus square root of 5. If I change it to this, x plus 2i, x minus 2i. And the reason why this works is if I take 2i times x, negative 2i times x, those cancel out. But 2i times negative 2i is negative 4i squared, which is negative 4 times negative 1, which is positive 4, which would give us x squared plus 4. So this is known as completely factored, which is a little different than your completely factored in Algebra 1 and Algebra 2. And there is yes square roots, and yes, there's i's in both of those. So that's known as completely factored. Okay? Let's do another example 6 here just for fun. And call it extra example 6. And let's go with x to the fourth plus 2x squared minus 63. So again, I'm going to try to factor first irreducible over the rationals, which means with no square roots and no i's. On that, I would have to have x squared times x squared to make x to the fourth, and then add to make x squared in the middle. Multiply to make negative 63. Add to make 2 would be positive 9 and negative 7. This is known as irreducible over the rationals. In your assignment, it may ask for all three parts. Irreducible over the reals indicates yes square roots, but no i's. To factor this, you have to have an I, but to factor this, you would just need square root of 7. So that would become x plus square root 7, x minus square root 7. And then x squared plus 9 would just come down. So that's what B would look like. C, completely factored, means yes square roots, so this is okay. X plus square root 7, x minus square root 7. And yes imaginaries, so x squared plus 9 essentially means x plus 3i. Oops, I forgot the I there. X plus 3i. X minus 3i, and I can do this because it's the positive 9 that I showed you before in the last example with that positive being there. That still looks pretty sloppy there, so x plus 3i. And that is how you do extra example number 6. Let's try number 55. It'll be on a separate video, so after you try 55 on your own, x to the fourth minus 6x squared minus 7, watch the next one, see if you can get it right.